Am I audible? Good morning, everyone. Prashant, am I audible?
Good morning, ma'am.
Audible. Audible. Thank you, sir.
Hi, all. Good morning. Hello, sir. I can see that this session is getting recorded. So, can we get the previous recording session? Is it possible? Hello, am I audible?
Yes,
Yes, sir.
yes, you are audible. You are totally audible.
Yeah, so is it possible to send those recording session?
Actually, in this regard, actually, it is a recommendation at the part of IGNO officials not to share the this recordings with the students, so that otherwise they will start attending the classes. This is a previous experience, and we have learned from that experience that once the student get this recording, they stop attending the classes. They refer from one another.
No,
So
that's fine. Actually, the thing, for few guys, we are not, yet confirmed that all those session is going to Arsad. That is the reason, we skipped those classes.
yeah.
So
Okay,
from
okay.
going onwards, we can follow all those, that suggestions. But the thing, for the earlier class, whatever the classes happened, so is it okay to send those classes from now onwards?
Okay.
You
Okay. So I think if recording will be allowed to be accessed by the student, then it is better to provide them into the dashboard basically. Whatever dashboard you are having onto the LMS, so the student can refer to that recording from that. So I will convey your message because we are having another meeting in the coming week with the even officials also. Then the things can be, I will just convey your message or your requirement basically, not the message, right?
okay? No issue. Thank you.
Okay. So now let's start the session, although still many students are in the queue, and but I have to start because we are having lots of syllabus also. So let's start. So today we have to start with the uh, block 1, unit 2. Yeah. So you all must be able to see the screen now. So these are the different topics that we all are going to cover today. Although I will cover this DFD creation as well as the ER diagram creation part. This part I will cover into the practical classes that are already scheduled. Not today, but today I will cover the entire blueprint of the practical classes which need to be covered under this. So you all must be aware of it. So let's start the session with the these aspect of the software engineering, because we all are here to know those. Just a minute. We all are here to learn all those aspects of the software engineering which really help us to create the a quality product. And again, what all mindset, what kind of the things must be there in the mind of software engineer, that all is going to be covered under this theoretical aspect of the software engineering. So let's cover now. Let's start this part with the help of this you know requirement engineering and all. So what is the basic aspect that we need to take care while engineering the product, or while developing the software by using some engineering practices and engineering approach. So here comes the concept of requirement engineering. Requirement engineering it totally revolves around all those aspects of the software which helps you to capture what part of the customer, that what the customer is looking for. So, requirement engineering is the systematic use of proven principles and techniques and language tools for the cost-effective analysis, documentation, ongoing evaluation of the user's needs and specification of external behavior of the system to satisfy those user needs. I told you in the last class that every time we have to keep in the heart of software engineering, we have to keep the customer here, so that everything it should revolve around the customer basically. So in the requirement engineering, we focus on to the basic user needs. Just a minute. Let me start with just a minute. My
voice is echoing. So, in between students are at attention, so
I
I
have
have
joined
joined
from
from
mobile.
mobile also.
मैम म्यूट कर लीजिए एक जगह पे.
Hmm.
Now,
Now,
okay,
okay,
na?
na?
नो मैम इनको हो रहा है दोनों जगह से माइक ऑन.
Now,
नाउ परफेक्ट मैम.
okay. So, मैं यहीं से एंट्री कर दूंगी इनकी.
Mute one device, ma'am.
Done. So yes, I was talking about the those aspects of the software engineering which revolves around.
मैम बहुत ज्यादा इको हो रहा है.
क्योंकि बीच में स्टूडेंट आए हैं बार डिस्टर्ब होता है तो आई थॉट कि इसका सोल्यूशन मिल जाए. इधर से तो इको ऑफ है एक मिनट इसका तो मिनिमम कर दूँ. नाउ ओके, नाउ बेटर देन अर्लियर.
नो मैम.
No, you can like turn off their mobile camera and put the mobile in some distance with laptop.
Okay. Yes. Now. I can still
Still you can.
अब देखो, shall I start now?
Yes, ma'am. Right now, okay.
Yeah.
Okay. Because I have kept it very far from my place, just to.
Again, the same problem.
Okay, let me stop now. Yeah. So yes, we have to talk. We have to capture the. We have to capture the exact requirement of the customer or user needs so that can be transformed into the form of specification, and that can be reflected in our software basically. So our today's effort will revolve around all those practices that we have to apply to capture the exact requirement of the customer. So while engineering the software product on the basis of their functionality, what the customer is looking for, we have to classify the requirement into two types. What are these two types? That is functional requirement and non-functional requirement. So functional requirement, these are those requirement which defines the factors like input output format, what all could be the possible storage structure, because every time if I'm going to create a web application, my entire data will be kept into the web server, and that web server needs a particular storage structure that we have what we have to configure. So everything in terms of functional requirement, we have to think in advance so that the things go in a smooth manner. And apart from this, we have to also take care of the computational capability, what all could be the timing and synchronization concerns that the customer is looking for into the software that we are going to develop, right? And in terms of non-functional requirement, we have to define those property or the quality of the product which are actually making the which are not are the prerequisite for the running of the software, but yes, they will play a very important role to make our software to be a very user-friendly software. So in this regard, where before delivering the software to the customer, we have to ensure the usability, efficiency constraints, and performance parameter, and the space, reliability, portability concerns, and all that we have to ensure so that non-functional requirement could provide better quality to the customer basically. Yes. So next one is Another important aspect of the software engineering is the preparation of the document, which plays a very important role. And sometime in some of the stuff, when you will go through with it, you will find out that it is said to be the backbone of the software engineering also. So yes, software requirement specification is one of the most important document, which gives the entire blueprint of the things what we as a software developer are going to do. And this is a perfect detailed description of the behavior of the system to be developed. So as the entire functionality of the software, it is being reflected by means of SRS. So yes, it sometimes said to be that yes, it by going through with the SRS of any software, you would be able to get an idea that what sort of behavior that particular software, what sort of functionality this particular software is going to perform, right? So keeping in view of all this idea, this SRS, the document which gives an idea about the customer requirement, and that is why it is said to be an kind of agreement document between the customer and the development team. What the customer has agreed upon, what the even if as a developer certain points are not possible that the customer has communicated me, and if certain gaps are there and I convince them that it won't be possible, the kind of in the language which you are looking for, it is not possible to implement this certain parameter. So how I have convinced, and on which parameter the customer has been convinced. So all these things will be reflected by means of SRS. There are certain clauses also. So, and the customer covering the functional and non-functional requirement of the software to be developed. So all these, kind of, ideas will be reflected by means of SRS. So yes, SRS is considered as a contract and the agreement between the customer and the developer. So if let's say I am the developer and you all are my client, and you have communicated certain parameters, and I haven't I have, let's say, manipulated certain things, or I have eliminated certain things, then that gap will be reflected once the software will be ready. So being the leader of your team, being the administrator of your software development team, what you have to ensure that the person who are going to connect with the customer, all the requirement must be taken out, and it must be documented also. You don't, even if the person is very genius or very superman or super person, but still everything must be documentation. Documentation plays a very, very important role. Even if you have n numbers of discussion with the client, keep everything onto the paper first, it should be documented first. Otherwise you can imagine the scenario, because this SRS document is playing a very important role. It is acting the role of agreement. It is acting the role as a contract between the two parties. So if something goes wrong or something gets missed out, so if as a developer I can claim against you, as a client you can claim against me, and we both can go to the government of India to resolve the case. So we don't want such a kind of scenario, so that everything must be in a documented way. So being the leader of your development team, because I told you in the very beginning that the entire software engineering effort, it revolves around the human skills and managerial skills and project management skills, and sometimes even administrative skills also. How the licensing between the two parties is being managed, it really creates a difference, right? Sometimes the quality of the software is one aspect, and the way how we handle it, it really creates the difference. So being the a key person of your organization, because we all are acting as a bridge between both the parties and all. So we have to take care of those as well, those who are having good communication, those who have a maturity of understanding. You must appoint that person into the team who can capture this sort of data and all, so that the things can be managed easily, right? So this is the idea that I want to communicate. Apart from this, SRS document will be used for verifying whether all the functional and non-functional requirement which was specified in the SRS are implemented in the product or not. Once the product is ready or the software is ready, then this SRS will again help us to cross-check the thing, that what was written into the SRS, is this all the parameters are reflected into my software or not. So if you are at the part of quality team, or you are at the part of audit team, or you are the part of administrative team, and all. So we all can, refer this SRS as a document of reference, so that the things can be, ensured that what the customer has asked for, is this serving the same purpose? Is there something gap, or everything is going up to the mark and everything? So these are the things we have to, taken care. The complete description of the function to be performed by the software is, reflecting into the SRS, because SRS will assist the potential user, either it is internal user or marketing team or the, designing team. So all the potential user who has to, take part into the development process, that will determine if the software specified meets their needs, or how the, software must be modified to meet their needs. Even if some gaps are, there, so that can also be, that idea can also be, captured out of this SRS document. So there is a defined structure that you all can see. I have captured this image from your IGNOU stuff only. This is the standard format, and in 8 to 10 marks, this is very popular question from the, examination point of view also. They popularly ask that define the, or write the SRS structure, or define the structure of the SRS, which is being used by the software developer to, before developing the software. So this idea you have to communicate in the same way, because this is a formal structure. I can't, shift one aspect of this, SRS to other one. So in the same way, the way it is reflecting in front of you, in the same way you have to reflect into your answer sheet also. My idea is that please don't change the sequence even. Although sometimes students say that, okay, I'm going to write this particular block here also. No, this is a very formal structure, or very formal, documentation process, which is being recommended by the IEEE standards also. So we have to, maintain this mandate. This structure is to be followed, and even the 10 marks question is specifically asked to write the structure for a particular problem. So we have to keep everything under this format. So now I will cover each and every aspect in detail also, that as a, when you are about to, because this part we will also cover under the practical aspect. I will assign you some topic, and then as per your topic, or as per the assigned topic, the candidate has to prepare the, SRS for that thing. So if that exercise is to be done, so it means definitely we have to understand each and everything what is to be right under each and every heading. So now you can have an idea that I think now everyone has an idea. So under the introduction part, now every section will be elaborated in a brief way. So under this introduction part, although it is not elaborated here, but still I am giving you some idea that entire, first section of the SRS, which is the introduction part, that must give an idea that what is the problem and how your software is going to be served as a solution to the problem. So in the introduction part, the stuff that you are going to write or you are going to reflect, that should not exceed more than one page. Only even half of the page can also work. Why I am using this term that half page or 1 page? Because when you are about to develop the synopsis for your project, because there is a project also under your curriculum. So in that we have to submit the synopsis up to 18 pages. So if my introduction will take, let's say, 2-3 pages, then how other things will be covered under this mandate or guidelines which was given by the IGNOU officials under the project guidelines. So I have to stick myself that introduction part should reflect P for problem, S for solution. That's it. Even a layman can understand what kind of solution you are going to quote in front of the problem. So it is the entire introduction. It should be very short and crispy, and it should reflect only that idea which your software is going to serve basically, right? Another important thing is purpose. So in this context, when we talk about the purpose, it means that purpose that you do understand very well, how your SRS, what's the purpose your SRS is going to serve. That purpose must be exclusively mentioned. It should not be any generic statement here. It should be very specific statement under this purpose part, right? Another important thing is who all are going to be your target audience who are going to use this software, because every time whenever the software developers are going to create a software, they keep everything revolve around the target audience who all are going to use your software. What is the capability of the end user who are going to use the software, who all could be the end user, stakeholder, every person. So your software is going to serve which target audience, that must also be specified under the purpose heading, right? Another important thing, scope. What will be the future prospect of the this software? Sometimes student or the candidate or whosoever is going to develop the software, they think that scope is an optional part, we can leave this thing. No, what could be the possible future of your software, that must be reflected with the scope statement. So we all have to mention we need to identify the scope of the implementation in the near future with respect to the software. That must be that part must be reflected into the scope part of your SRS, and your scope dimension should also specify that what the system will do and what it will not do. Sometime once I could remember one of the scenario when I was the part of project panel or a project Viva, basically that panel. So one of the concerned person has asked a question that tell me something about the weakness or limitations or shortcomings of your project or your product, and that student has answered. I'm not blaming anyone, but I'm just considering. I just want to put one point over here or submit one point over here, that how important it is, because keeping aside all the things, if we know what our system or software can't do, it is another important aspect that must be reflected into the scope part. So if I have really developed a software, I have really worked onto that particular software, then I must be definitely aware of what my software system can do and what it cannot do. So your scope statement should reflect the capability of the software that software is going to serve. Describe the user classes and benefit for each. What all could be the possible user classes that we are going to cover under this software, that must be reflected under this scope part, right? So this is the important part. This is not an optional part. Just one point I want to submit here, and of course that we do understand very well that software development is a one-time effort and software maintenance is an ongoing process. So it happens most of the time that I have developed a software, but I'm not a part of that organization. So I move to some other organization, then another person take on that responsibility. So how the maintenance gaps will be resolved. So keeping in view of that idea into the mind, this specific heading or section or component has been added into the SRS, that whatever abbreviation, whatever acronyms I have used in the development of the software and all, so that must be reflected, so that the other person who is going to manage the software, that he can manage the things very well after going through with the acronym and abbreviation part. So another important thing that is the part of introduction heading under the SRS is the references. Either my software has created a success story or a horror story. In both the cases, we must be very much interested in knowing the sources of the information that has motivated us or that has encouraged us to create such a horror or success story. So all the references we have to mention under this heading. So even again, so there is some sort of mistake that the candidate used to perform over here or learner used to perform. They just refer that google.com, yahoo.com, or let's say youtube.com, or let's say facebook.com or wikipedia.com. No. Wherever you are going on Google, which link has helped you in getting some ideas or in even some sort of coding. If I visited to the, let's say, Quora.com and I got an idea, or let's say some people or some IT professional or some development kind of a team has helped me to get and optimize my code also. So I can take the source of that Quora link also into my reference section. Even I have gone through with some books. in books in the books also you need to mention which block, which unit, which section, that you can also mention. Although it is also recommended if you will just mention that okay, I have gone through with a MCS-217, let's say block 2 and unit 7, or let's say unit 3, even it is also okay. So what exact sources we have captured in the development of in that software and all, yes, that is why it is always recommended to put the value of this reference section at last, because once your software is ready, then only this heading can be done. But yes, 2-3 references at the part of synopsis can be included into the reference section. And overall overview, this is a 360-degree view of your software that gives the idea to the other person who is going to have an overview of the, or sometimes we can say different stakeholders will not get into deep dive into the each and every detail of the software. They just want to have a holistic view of the software, what your software is actually going to do. Or see, even sometimes we have to use some generic statement also in terms of what all can be done with the help of this particular software. So that overview, it will describe the kind of content also in the rest of the SRS that we are going to cover, and how the SRS is going to be organized. So all these aspects will be covered under this introduction part only. Now I am going to cover another section which is called as an overall description. So till now what we have done, we have covered only the introduction part. Now what we are going to do, we are going to cover overall description, which is the second section of the SRS. So under this, when we talk about the, because overall description will be explained or will be reflected in terms of the product perspective, and in this example, and of course because we are all are going to connect everything with that of the software. So in this example, the product is what? The product is our software product. What perspective and functionality and what kind of user to whom this software is going to serve, that can be reflected with the help of user characteristics and all. Now I'm going to cover one by one. So product perspective, it will present the business case and the operational cost of the concept of the system. Because in the first class we talked about that yes, software engineering has a direct relationship with that of the business world, and the entire success of software engineering revolves around the usage of our software that we are going to develop. So product perspective covers those aspects of the business case and operational cost of the concept of the system. It describes how the proposed system, because sometimes it is a good idea to develop the software from the scratch, and sometimes it is a good idea to amend the existing software or customize the existing software so that it can serve the business context and all. So how our proposed system will fit into the business context, that idea will be reflected by means of product perspective. It will also describe the constraint in terms of memory, because software always software is such an entity which always needs some storage space and other operating parameters that must be satisfied for the running of that particular software, and how the your site will be adaptable. All these aspects will be, you have to exclusively mention under the product perspective. Functions of the software product, it will give a concise idea or brief or summary part of the major functionality of the system, of the software basically. So we have to include those use case diagram, although it is a UML approach or unified modeling approach. Under this there are 14 types of diagrams are there, and every diagram breaks some sort of complexity also. So by means of use case diagram, we reflect how a user will interact with the system or software, and how the things will move on. So as a whole, we can get a bigger picture of the thing in terms of use case diagram and all. So and that will really help us, that who all are going to be the actor or the player who will participate into the transaction as a part of software and all. So that can also be reflected when we talk about the different functions of the software. That functionality can also be elaborated or can be reflected by means of proper DFD or data flow diagram also. User characteristics. User could be anything. There are different stakeholders, internal team users, your client, that marketing team, designing team. Every player they fall under this category. So we have to, describe and justify all the technical aspect and capability of each user class so that our software, for which our software is going to serve. And constraints are an integral component of any software. There would be different types of constraints which could affect the, normal functionality of the software. So these constraints, they basically describe other constraints that will limit the developer's option, regulatory policies, target platform, and database, parameters, and network software protocols development and standard requirement, because everything must be in sync with all these things, with all these parameters also. So that constraint we have to always consider. That is why when you are going, when you will actually develop the synopsis for your software or your project basically, then there's a specific heading as per the recommendation of the SRS officials, that in one paper you have to specify that what could be the possible software requirement or hardware requirement for the smooth running of this particular software. So all these things must be mentioned under the constraint part. Assumption and dependency. Assumption and dependency plays a very important role, because in the first class we talked about that yes, there are entire software engineering works on to the principle. They basically not principle, I should call it. I should call it as a futuristic approach that the software engineering paradigm basically follow, and that futuristic approach is totally based on to the assumption and sometimes dependencies also. So we have to this aspect will basically it states that the assumption about the availability of certain resources, that if not satisfied, it can alter the requirement, or it can have an impact onto the overall functionality of the software. So all these aspects we have to consider while defining the overall description of the software. Now the way we are going ahead into this journey of structure of SRS and all. So I hope you all would be able to get an idea that okay, in the first class we talked about different fact finding technique also, we talked about all these things in our practical classes also. So yes, this kind of structure of SRS is also giving some idea that what our discussion with the client must be done in a very planned way, and that discussion should revolve around all these aspects that we have to capture. So while planning the meeting with your client and all, so have this idea into your mind, prepare your questionnaires accordingly, so that the productive meetings or the productive outcome can be find out or can be generated out of it. Right. Another important aspect is that, which is specific requirement, because our entire software engineering approach, it moves onto the modus operandi of generic to specific one. So now this specific requirement section, it revolves around that aspect only, in which we have to specify the external interfaces in terms of what all inputs and output is to be required under this software. And the things should not be duplicated, because everything in IT or in computer or in software takes place. So we should avoid the duplicacy of data also. Information must be presented in a well-defined format or well-defined interfaces also. That is why different GUI screens and format is to be defined in advance. And apart from this, when it comes to the different functions, so these functions should reflect the detailed specification of each use case, including collaboration, another diagram, activity diagram. When the UML part will be covered, also that will be covered hopefully by last class only. So in that we will get to know different kind of use case also, that will give you an idea that how the functionality of the software can be reflected with the help of different diagrams. And when it comes to the performance requirement, then we have to specify that how the performance of the software can be improved. What what kind of practices must be applied into the development of the software that will ultimately improve the performance in terms of memory, in terms of computing time, in terms of other aesthetic part of the software also. Logical database requirement, in this we have to include the different types of information which is used in the development of the database, and again it revolves around the kind of requirement of the software. So when we are discussing everything, we have to identify different entities and how one entity is related with that of the another entity, and that aspect will actually define the relationship at the part of the between the two entities basically. That we will cover in detail when we will cover the entity relationship diagram also. Design constraint. Design constraint in this, what should be there to give a feel good factor, or uh, to make a connect with the client and all. So that should include the standard compliance also, and accounting, and all the business rules with that of the auditing procedures that must be ensured also under this heading, design constraint. And although software system quality attributes play a very important role, but our entire aspect revolves around the quality which actually satisfied our client, and that could be accuracy, that could be security. There are different aspects that we are going to cover further also, because entire unit is based on this quality attributes and all. Another important thing is object-oriented models. So the main body of the requirement, which are organized in a variety of possible ways, are architecture specification. So when object-oriented models are to be chosen, so we have to specify the best possible ways which will reflect the object-oriented model in terms of architecture specification, class diagram, state and collaboration diagram, and activity diagram. Although I have just given you an idea that UML includes the 14 kind of diagram, but again we have to remember this thing, that it is not always recommended to prepare all the 14 kind of diagram into the object oriented model, because wherever you will find any sort of complexity, just to break that complexity with whatever diagram or whatever diagram is that you can choose to break the complexity, that should be created. Right? If I'm facing some sort of challenge in defining the functionality of my software of a particular process, that activity diagram will serve the purpose. Right? If more component is to be integrated, I'm just facing some sort of challenges over there, so that the collaboration diagram will serve the purpose. So depending upon the complexity that we are going to face under this software development work, accordingly we have to make the object-oriented model based onto that aspect only, right? Requirement goes gathering tools. Just a minute.
Which diagram you have said? Sorry.
Just a minute.
Ma'am, what's the base of UML diagram? UML.
Just a minute. So we have just talked. Let me open that. So actually, a unified modeling language is one of the fantastic approach which is being used by the development team members to break the complexity at different level when we face any sort of gaps and all. Not sometimes even just to resolve the gap, rather it's a good way to create the UML diagram that breaks the complexity, right? I will, although the last unit or the fourth block, we will cover a little bit part of it, because in the second semester you are having a complete subject based onto the UML, that is object-oriented programming and all. So that is totally concept which is based onto the UML. The only idea that I just want to quote here, or I just want to submit here, is that under the UML diagram is a tool in the hands of software developer that really help us to break the complexity at different levels. So there are 14 kinds of diagrams that will come under the object-oriented model, and each diagram is there to serve a purpose. And although I have clearly mentioned this thing that all the 14 types of diagrams are not recommended at all in every software. Wherever I will find any sort of challenges, just to break that challenge, I will because every diagram has its own purpose behind it. So once you know different kinds of diagrams and all, then you will get to know that, okay, now I'm facing this particular kind of challenge, and to break this challenge, I need to create this diagram. Then only me as well as my team will be able to understand the thing. And just by a simple, small, generic example, I just want to quote one example in front of you. That can anyone tell me that how many circles I have drawn? Although these are very, can anyone give me an idea how many circles I have, drawn under this diagram? Any idea? Any guesses even? No. No, no? No.
N numbers.
N number. No, not N number, we can define it. But anyway, less than 20 or less than 15 we can say. Although it is not the blueprint of my brain, which is in front of you in the terms of these red circles.
Ma'am, one question. In IGNOU book, in specific requirement, there is no object-oriented model. Only organizing the specific requirement they have given.
Just go to the block 4. I think unit number 15 or maybe 16 also, last. That here is a section which is called UML. I hope you were in the beginning of the block, but yes, there is a section. So I just review that in the semester number 2, there will be a complete subject on to the object-oriented analysis and designing. And this is all the things which must be done before the actual development of the software. Because my idea was that if I have n numbers of, let's say, 5 or 7 discussions with my client, and even after having so many discussion, still the things are overlapping. As you can imagine this diagram which is in front of you as one of the blueprint which is created after discussion with my client. So if I have such a overlapping of thoughts into my mind, do you think that I can create a good software or successful software? No, not at all, right? But UML here comes as a blessing part for the software engineer. They define each and everything in a very, there is a boundary inside each and everything. Now everyone can imagine the kind of the things which are covered under this. That now in the second example that I have narrated in front of you, everyone can count the number of circles. This is circle number 1, this is circle number 2, and this is circle number, let's say, 3. So now my understanding about the problem is clear. And here comes the role of different 14 UML diagrams. Previously, I was not able to understand the thing because things were not clear. Now the things are going to be much better because my understanding about the problem is going to enhance. And here the object-oriented model, which is totally based onto the UML diagram or 14 UML diagram, it is serving the purpose. So I hope, although I'm not going to cover all those 14 diagrams here also, even in the last unit also, I will not cover that one by one each and every diagram. But yes, when we will meet into the second semester, then I will even let you know how to create each and every diagram also, right? So that is the thing. So I hope you all are getting my idea that basically the success of any software depends how beautifully, not how beautifully, how correctly and how appropriately I have captured the requirement of the client. So once that requirement has been captured clearly, then only the successful software can be imagined, right? So this is the only idea of introducing object-oriented model into the SRS section. Another important thing is requirement gathering too. Although most of the things we have already covered into the practical part also, but yes, there's a direct 10 marks question that will be asked into the examination that you are going to have into in the month of August, so mid of August, or let's say mid of August or end of the August also. So there is a direct question in which they ask for that what fact-finding techniques will be used by the software engineer to gather the requirement of the client. So now this section is basically going to answer this question that yes, the requirement gathering is an art. Really, it's an art. The person who gathers the requirement should have the knowledge of what is to be done and when to gather the information and by what resources. So all these, when we talk about requirement, so it means any requirement is said to be complete requirement if it serves two important aspects. One is the what part, what we are going to cover, and another is how part. So this W and H family, these questions, they will basically, actually generating the requirement that as a software engineer we have to capture. Once they are captured, then only the things can be go to the next level. So there are 4 fact-finding techniques, although we have discussed more than 4 also in the practical classes, that yes, it is always a good idea to review the previous records or past record or historical data, because historical data, if that history is good or success stories are there into the past, then the success story in the future can also be implemented. We all can capture this idea from the that entertainment industry, because once any movie or any movie is successful, then after some time that same producer director, they give a next series of that movie. This is part 1, this is part 2, and so on, right? So similarly, we have copy pasted, because we all software engineer are here and we love the concept of copy paste, because rather I must say that the entire our industry is getting the idea 70% from the industry, which are our success story, which are already created. So record review is, yes, it's a really brilliant idea to get a review of recorded document of the organization is performed. So procedure, what kind of document you are recommending me to review for? So here comes the answer of that question. If I'm going to create a software for a particular client, I can ask for some sort of procedure that they follow, and if there is no documentation, then again we can create or we can ask for that procedure in a documented way. We can refer their manuals that they follow, what kind of forms or interfaces, even some support materials are there that can be reviewed to get the format and different functions of the system basically. So the search time in this technique is more. Yes, because every time until unless I will not review all the documents, then the entire picture will not be clear to me. It is a time-consuming activity, but yes, it is a foolproof formula that it will give me a better idea of the things that I'm going to transform. So one point was record the review, because my idea is to gather the data with respect to the software that I'm going to develop. Another is on-site visit. Let's go to visit to that particular site to get an actual, realistic data, because sometimes it depends upon the capability of the person who is going to involve or indulge into the discussion. If that person is giving me complete idea, then no issue. But if that person is not having the complete understanding, or something is being left at the part of that person, so that will really create a gap, right? So I don't want to have that gap, because I could remember that diagram, that the Gandewala diagram, that will give me that is not giving me the complete picture. So I'm not here to again create that gap over here. So in that case, I will actually visit to that site for which I'm going to develop the software. So it will give me a close look of the system, and again the certain unsaid parameter will be covered by when I will visit to that particular site for which I'm going to develop the software. It will also help the analyst to detect the problem of existing system. Sometimes, let's say, if I have visited to some place to get the exact picture of the things, then certain things were arising in front of me. So that can also be included into the proposed system basically that we are going to develop. Again, interview is a important tool that we can use to gather the requirement. So we can have 2, 3, or 5 meetings also. I told you we have discussed all these aspects into the practical classes also, that we can't limit the number of meetings with just by a count. Until and unless my requirement will not be clear, I will keep on meeting with my client so that the things become more clear with the staff. So a personal interaction with the staff is performed to identify their requirement, and sometimes certain people are of that level, they don't convey you complete information also, and they don't know what you are looking for basically. So it is the job of software engineering or the software development team which has to capture or prepare their question in this way so that they can get an entire boundary of the things that they have to implement in terms of software also. So yes, it requires experience of arranging the interviews and setting the stage and avoiding the arguments and evaluating the outcome also. Although this aspect we have covered already into our practical classes also, that there must be a facilitator of the team also. So if some heating arguments is exchange between 2 or 3 person in the team, it happens because everyone is there to create a quality software, but everyone has its own mindset, his own lens of thinking and all. So no, we should appreciate the differences and we should respect the similarities also. So keeping in view of all those things, we have to appoint a facilitator of the meeting while having such kind of healthy discussion and all, so that the things should be under control. And the outcome, the idea is what basically for the agenda of the meeting should be satisfied also, or it should come out, right? Questionnaires are another important tool in the hands of software engineer. It is an effective tool which requires less effort, and it produces a written document about the requirement also. It examines a large number of respondents simultaneously and get customized answer also. And the beautiful part is that questionnaires, once they are set, so then the things can be planned accordingly. So it gives person sufficient time to even to answer all the queries which you have mentioned under the questionnaires part also. Apart from this, this questionnaires tool, on-site visit, interviews, and record review aspect, different case studies can also be gone through under the requirement gathering tool by the software developer, and we can have a healthy discussion with the end user also, and internal team member also. They will give us some better idea in terms of requirement also, right? Next comes the concept of system modeling. Before going ahead on this part, let me show you this diagram first. This diagram will give you an aspect that we must have in our mind, that every software is always a part of any system. No software can exist in isolation. It is always going to serve a system basically. So whenever we are going to develop a software, we have to give a specific thought to this part in terms of system modeling. So okay, if I'm going to develop the chemist for a chemistry department, I'm going to serve a software, or I'm going to create a software so that all the who are going to be the part of this department or chemistry department. So how this software will serve every software or every department. It is a part of any college. Every college is a part of a university, and every university is a part of some education system, national or international education system. So now you can think that this hierarchical way of thinking, that how one aspect of the software is related with that of the another, and if it is related, it can impact that aspect also. So that way of thinking, in which we have to again think in terms of entire a 360-degree level. So whenever the system concept comes, we have to consider this circle in our mind. So it means this circle will cover all the aspect of the 360-degree. So you have to consider that, okay, who all are going to be is to be related with this thing. So this way of thinking is basically called as a system modeling. So yes, system modeling is a process of developing abstract model, that conceptual model of a system that we have, because sometimes even let's say entire class, in this class right now, more than 60 plus students are there, including me and all. So maybe we all are creating the software for the same industry, but still system modeling can't be same for all the things. Every organization has its own set of requirement, its own set of modus operandi and all. So entire system modeling concept will revolve around the kind of conceptual model that we are going to use to develop that particular software or system. And every model should in sync with the model that we are going to use, because in the past class we talked about different sort of models also, and you could be able to remember that CMM model also, that was a kind of effort to increase the capability of the software industry to better serve the customer and all. So it presenting a different view or perspective of the system. So system modeling, it provide you a specific lens of thinking to the software developer, so that our software can the landscape of that software usage can be enhanced. Another so under this system modeling, what I am going to cover, but we have to cover other environmental model. So this environmental model it basically indicates the environment in which the system exists, on which particular environment, and to cover this dimension every time whenever you are going to develop any sort of software. So there is a specific system configuration is to be asked by the development team from the concerned person, so that in which particular working environment your software has to be survived. So it then even we have to raise such a question also that can help us to get an idea that in which environment this particular software will execute. So any big or small system is a subsystem of the large system that we have just get an idea. So yes, if software is developed for a college and then college will be the part of university, we have just gone through with this particular scenario with the help of this particular diagram. So this way of thinking will again help you, will really help you to provide a better idea of the software as well. DFD. DFD yes, it will give you a better idea, system modeling, how the system modeling will be, will reflect their ideas and all. So in this context, behavioral models will play a very important role. They will describe the overall behavior of the system that your software or our system is going to serve. So in this tool, in this process entire, there are two tools that, although I am not going to cover this part in detail, because this part we will cover into the practical classes. So, but I will let you know the purpose of each and every diagram that will really serve the purpose. Data flow diagram will actually give us an physical flow of the data that will be taken place in the software. And before creating the DFD diagram, we have to create ER diagram, so that we have to identify the different entities who all are involved into this process in the flow of data. So how the two entities are related with one another. ER diagram will give a bigger picture of the things in that context, and what data dictionary or what specification I'm going to use in the implementation of all these things, that will be reflected in terms of the data dictionary. Data dictionary is a kind of meta dictionary which gives some idea about the terminology that I have used into the development of that system. Sometimes we use a particular, let's say, variable CID, and CID doesn't convey any meaning. So some people are taking it as a client ID, some people has mentioned in their project as a customer ID, some people has mentioned it as a another important control ID and all. So data dictionary will will resolve such kind of confusion. Once you will go through with the data dictionary, then the things will be much clear at your part, and then that will really help us to maintain the software also. So all these and process specification, because every software is going to serve some purpose, and that purpose will be specifically reflected in terms of different processes that our software is going to reflect. Let's say if I have created a web application, then the first process is the registration process. Second one is, let's say, login process. Once I get into the dashboard, then what kind of transaction I can perform as a user, I can perform as an admin. All these things will come under the process specification part. So by knowing or by going through with the DFD part and entity relationship diagram and data dictionary, the things will be more mature you to understand the thing, And then again, if our understanding about the problem is much better, much mature, much clearer, then clarity of thought is most important in the software engineering. So so all these tool, including UML, all these tools are really helping me as a software developer to resolve my confusion, or to improve rather, or to optimize my you know understanding about the problem and all. So yes, there are different levels of DFD also. Every time we have to, when we start our journey with that of the DFD and all, we have to create a firstly the context level DFD first, which is also called as a zero level DFD. Then it comes first level DFD, then second level DFD. In most of the online stuff or digital stuff that you are referring through the Google and all, and other informative stuff in terms of books and that you will be referring, every time you have to reflect the DFD by the level of 2. Although it can go beyond of 2, but wherever you will find some example, you will find it up to the level of 2. So even if you are facing some sort of question, sometimes it is written very clearly, it is written into your question paper that create only context level diagram or zero level DFD, because that if they have limit us to this level, then we have to go to that level only. But if they have just simply written a statement that create a DFD or data flow diagram for the library information system, so we have to get an idea that yes, we have to go till the level of 2 or second level. So we have to create the DFD diagram till level 2. So this is a small tip that I want to give. Sometimes students get confused. Every tool, whatever tools and we are going to use, I have just told you that we will cover all these things into the practical classes, but just for the sake of your understanding, because it is in front of you. So all these 4 tools are specifically, or symbols basically, we will use in the creation of DFD also. Although again a small tip for you, that the way your examination center will be allocated by the IGNOU, similarly your practical exam center will also be allocated to all of you. So in this context, even we are having n numbers of free or open source available for the creation of DFD and diagrams and all. Still, I will recommend you that you should, because all these symbols, they are not specific. They can be found in any word processing software like MS Word also. So even if you have hands-on on some software, you are good at that part. Still, you practice for the creation of DFD diagram onto MS Word also. It is one of my recommendation, one of my tips, because once it happens that wherever will be your examination center, maybe they don't have a specific software on which you have already practiced it. But MS Word or MS Office is such a software that you will find everywhere. So if you are well versed with the creation of DFD into MS Word, that will really help you to cope up with the situation that you can face in the near future. So this is a small thing. So what is the meaning of every DFD and all, that we will cover. I'm not going to waste that time here also. So that we will cover into the practical classes with some suitable diagram. Now I'm just going to give you a brief of ER diagram also. ER diagram involved, which is called as the entity relationship diagram also. It gives us a better idea in terms of who all are involved into the transaction, who all are participating into the different transaction which is to be performed as a part of software. So ER diagram, although identification of ER entities is really a very tedious task, it takes time to understand the thing. Sometimes we have to again do lots of what we call it as a brainstorming, kind of session with the client and all, so that we can exactly identify the entities which are involved into the transactions and all. So yes, it is not so easy to identify the entity, but what all are the tips to identify those entities and all, that we will be covering under the ER diagram. So yes, entity is the most elementary thing of any organization about which data is to be maintained. So now, and every entity has a relationship with that of the another entity, and that relationship can be defined in terms of one-to-one relationship, one-to-many relationship, many-to-many relationship, and many-to-one relationship. Now, if based on this, this understanding, I just want to quote one point over here that in this class where Sumita Tukral is taking the class of MCS-213 for the MCS-213 student. So in this, interaction, whatever these two, in this, interaction, two entities are involved. One is the faculty, another one is the student. And the kind of relationship is what? I am teaching more than one student. So this is one-to-many kind of relationship. So how the user is interacting with that of the system. So we have to understand in this way. It is a very small example, although there are a lot many examples we will cover under the practical classes also. There we will go through with different scenarios also there that will really help us to identify the entity with respect to different industries and all. So entity is anything which can be, defined in terms of different features or adjectives or features. That is called as an entity. Any book can also be an example. Facebook is also one of the example of an entity. WhatsApp is also, because everything they have some specific features and adjectives and particulars with them. So that can be defined in terms of entity. And in broader terms, if we talk about the entity, so whatever definition you understood with respect to the object is equal to entity. So with this understanding, we are going ahead on to this part. There's a cardinality and optionality is also there, because sometimes certain features are optional. Cardinality basically reflects the degree of association between the two entities and all. So here this small example is giving you an idea that how a class and student, every class is a class only if it is consist of students. So this kind of cardinality is reflected with the help of this ER diagram. So once you know ER diagram is ready with us, then the database manager can or DBA can start working on to this part. I'll so that they can define the structure of the database or tables or different data types and kind of the primary key, foreign key, everything can be defined. But once the ER diagram is ready, right? So all these aspects we will cover in detail and in practical classes also. Attribute that we have, although attribute is the right and correct word that we have to use in context of ER diagram. So every entity is having some sort of attribute that are associated with that particular entity, that is called as an attribute. So you can all see this example that how the student attribute, this having a different features or characteristics or adjective. Every student must be the part of any class. They must have some marks and address and this and this one. So all this we are giving you a better picture. Once this sort of diagram is or ERD is ready with us, so that understanding document or that designing document can be shared with that of the coder, and that coder will give a complete idea that okay, what could be the possible kind of field name into the database or that they have to use in terms of coding and all. Another important thing is software prototyping and specification. So prototype is what basically it may be categorized. A prototype may be categorized as follows. That is, a prototype which is a model depicting human-machine interaction, because prototype gives us a better idea in terms of understanding. We have talked about a little bit on this in the first class also when we talked about prototype model and all. So prototype is here we are talking about the paper prototype, means whatever idea is being communicated by the client. I have jot down into the paper so that I can get a outline of the things what all we have to transform into the software and all. So yes, it is a model which depicts human-machine interaction in a form that makes the user understand how such interaction will cover. So a prototype is a working prototype which is implementing a subset of complete features. Once that prototype is ready with us, then we can get an idea that okay, when a fully fledged software will be ready to launch, that what kind of features it will reflect. So once the prototype is ready, that That idea can be generated out of this prototype. So an existing program that performs all of the desired functions, but additional features are or can also be added into this prototype for the sake of optimization, for the sake of improvement. So yes, prototype is developed so that the customer, user, developer, who all are who all are the different players into the development part, they all can learn more about the problem. So basic means the from the very beginning till now, whatever I have covered, it is totally revolving around the understanding part about the problem only, right? So thus the prototype they are serving as a mechanism for identifying the exact requirement of the software. This again, this diagram we have already covered into the prototype model. Also, that entire journey of prototyping, it start with the because prototyping is the complete process basically, and the outcome of the prototyping is called as a prototype, right? So requirement is to be gathered quickly, design is to be prepared, again coding is to be done, customer then that ready part is to be evaluated by the customer first, and then the things will keep on refining until unless my client is not satisfied. And once the thumbs up is there, my client is ready, my client is satisfied with the requirement or with the functionality that this prototype is going to offer, then it means that software production can be started at the mass level, and then the engineered product will be ready to launch. So this is how this entire journey of things goes to the next level. Next comes software metrics. So software metrics are what basically? Any calculated value in the very beginning, we have learned about a definition which is called as a Q square formula. One Q stands for quality software, another Q stands for quantity software, quantitative approach. So that quantitative value is what basically it is the software matrix. There are different examples of the matrix that you must be having already into your mind, that okay, what is the title of the for which particular industry we are going to serve, or we are going to make this particular software, who all are the end user, okay, how many people will be involved, who what is the language, what are the compatibility parameter, what is this the software should be browser friendly, and all these things, for how many lines of code, how which language, which software, which protocols should be supported, every aspect of the software, it is a kind of matrix, it's a kind of calculated value. So here comes the role of software matrix. So because in the just half an hour back, we have talked about that it's a brilliant idea to refer the historical data of the previous project, because entire software engineering is a project management. It basically works on to the principles of project management. So in the implementation of project management approach, we always look for the matrix or calculated value. So that calculated value or matrix are having an agenda behind it, that these are the objective software metrics are the objective and quantitative data that is used to measure different characteristics of the software system or the software development process. So using the software metrics, software engineers, they measure the software processes and requirement for that process. Okay, I'm taking an example. Let's say I have created a SRS. There are, let's say, 20 points were there that I have to reflect in terms of my software. So that 20 points that must be reflected into the software is a kind of metric. When I will about to deliver this particular software to my client. Before delivering to the client, I will just ensure either all the 20 points are being now reflecting into the software. The client will be able to have that implementation of that 20 points or not. So this matrix will help you in tracking of the things also. So the software measures are done according to the following parameters. What all are these? Let's cover that thing also. So the objective of the software and the problem associated with current activities that must be reflected in terms of matrix basically. What all is the objective, knowing objective of the software, and what all could be the possible challenges. Although I don't like this particular word, there's in the dictionary of software engineer there is no such word which is called as a problem. Rather, we should call it as a challenge. Yes, there are certain challenges into the software industry where we are not able to find the solution then and there when they arise. These kind of challenges arise. But yes, with the passage of time, there are certain things which gradually resolve with the passage of time. So take it, again, this is the kind of mindset only. So this, matrix will really help us to again track the things and the cost, what all could be the cost drivers of this particular software. So the cost of the software required for the relevant planning and related to the future project, all these again is a kind of metric, right? If some specific, consultancy I have to take to, evaluate the cost part of this particular software. So again, getting consultancy means it's a cost to the organization and all. So how all these things will be, will be the part of that software metric. Testability, maintainability of various processes and product. Again, after testing a particular software and while maintaining the software, there are certain things that need to be done. What all that can be done? Again, that parameter, the value of these questions will again serve the a kind of matrix to you. Quality of the software attribute like reliability of the software, because every time our software, it rather I must say that it should be the default feature of every software that our software must be reliable enough. Reliable and safety are the two important sides of the same coin, and our software, without even if the client has not communicated anything in this regard, still it is the it should be the religion of every software developer to take care of this aspect of the quality of the software, basically. Portability and maintainability. So all these parameters, they will basically serve the purpose in terms of the software matrix. Just a minute. Yes, yes, yes. Uh, hmm. So yes. So with this, your block one, unit two finished now. I'm going to start the unit three also. So this, unit three, it will totally revolves around those aspects of the software which are about related to that of the designing phase of the software and all. I think someone is trying to enter. So these are the topics that we are going to cover. This is the basic, understanding about the software design. There are two important documents which are mandatory into the software, that is SRS and SDD. SDD stands for Software Design Document, and SRS stands for SRS, that is Software Requirement Specification Document. So with the help of this diagram, you will be able to get an idea that how the user requirement are being transformed into the form of information model, and that information model again helps in the building up of the function aspect of the software, and all these again all these inputs again give you a kind of idea which help you to apply the system modeling concept, and once the system modeling concept is ready with us, then it gives rise to the system design. And after creating the system design, the output that we take as an input to the coding phase is the data design which has been captured from the system design. And that coder will get an idea in terms of procedure and all that they have to implement into this particular software. So this entire diagram is giving you a complete idea in terms of how the journey of transformation basically carries out at the part of development and all. And if some certain gaps are there, let's say on this phase or let's say on this phase, then definitely it will reflect here also, right? So it is a part of responsibility of each and every member, whosoever is a part of at which level they are working. They have to ensure that the things must be reflected completely into this SDD document, that is software design document, right? So if the things are included into that one, then the that will reflect into the code part or into the final version of the software basically. So here comes now we will elaborate each and every part. Data design. Data design is the first and foremost activity of the system design. Data describes the real world information resource which is important for the application, because data every time every software is a kind of doctor because it is serving to a purpose for the organization, but it will work only if the data is there. So yes, that is why it is described that data is the important resource on which any software will work. So data describe various entities like customer, people. That data could, it could be of any kind of, because it depends upon the type of software that we are for which we are collecting the data. Primary objective of the data design is to select the logical representation of the data. Once I will understand the entity, then I will understand the data part. Then we can, because entire data, getting this data design is a kind of data modeling approach which help us to define the requirement at the after analyzing and all. So that will really help us to transform it into the various fields of the table in the database as well. Architectural design. So the objective of architectural design is to develop a model of software architecture which gives an overall organization of the program module in the software product. So overall, a holistic view of a software can be captured with the help of
Ma'am,
architectural design.
sorry for interrupting us. Can you please explain again procedural design?
Which one?
Procedural design.
Procedural design. Okay.
Yes, ma'am.
You are talking about this one now? Here?
Yes, ma'am.
Okay. I'm taking one example to make my point to be clear. Let's say in application, I have make a procedure that there's a registration process, and after registration, the registered user can log in into my application. And on the login, there's a login and password option, and that these two parameter will be input by the user under this interface. This is one procedure, right? You are also having an application, you have also make the same procedure. You have included one important another aspect under this uh, 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 login interface, that is forgot password. Although we are, let's say for this example we can consider we both are creating the registration and login module, but in my there was no forgot password option was available, but in your interface it was there. So the things were going on, but every procedure has its own design parameter, right? So this is what I want to convey, that every procedure, what all you have, you want to achieve, that must be reflected with that, with the help of that design. You got an idea? Because our designing will reflect the kind of functionality that will be reflected by our software. You're getting some idea? Yes? Your question is answered?
Yes, ma'am. Thank you.
Okay. So to get a complete idea of the architectural design, this is a kind of again image that I have captured from your Igno blocks only. That yes, there is a financial accounting management system or software. This entire functionality can be reflected in terms of account receivable and fixed asset and sundry debtors and all. So once this architecture, this holistic idea is we are having, then the entire functionality of the software can be reflected. So the objective of architectural design is to control the relationship between the modules. Now this is the this is one of the parent module which is controlling all other what we call it as a child module basically. So yes, one module may control another module or may be controlled by another module also. So this kind of hierarchical, organization of the thing will really help us to structure the things in a much better way and to generate a better, user experience also. Because the journey of every software will be evaluated in terms of the end user, in terms of the client or customer for which this software is to be developed. So architectural design will give you a complete idea in terms of different modules and how they are interdependent on one another or interdependent also on one another. Apart from this, architectural design, it is the organization of the module which can be represented through the tree-like structure that we have just seen with the example of, with the help of that example, and the number of components. Now, if let's say there are a lot many component I have included here, so after looking at the different component, even the complexity of the software can also be judged, right? If let's say here 20 such kind of component will be involved. So after going through with that architectural design, we will get an idea that okay, lots of parameter or components are involved into it, right? So on the basis of which this component is said to have a fan in and fan out ratio. So here the fan in means the number of incoming edges which are entering into a component, and the number of components that are controlled by the module is called as a fan out ratio. So that you can capture from this particular diagram that here S naught, the outgoing edges of this S naught is S1, S2 and S3, and S1 and S3 are collectively entering into the S2. So this architectural design help you to get an idea in terms of the kind of modules which are related with one another, and even the kind of complexity also which are involved into the designing of this system, right? Modular design. Although modular design is one of the most important concept which is a kind of analytical modeling concept also, because it helps us to break the entire complexity of the software into the small module, and that small module can actually generate the functionality of the software basically. So the concept of modular approach has been derived from the fundamental concept of divide and conquer strategy. That is the if there is a bigger problem, or not problem rather challenge, then divide this challenge into the smaller pieces and then tackle each and every piece of challenge one by one. Then at last you will be able to resolve all the problems. This is the concept of modular design. So if at any point of time we are facing some sort of challenges or complexity, we have to apply this strategy of our working into the team also. Rather, we should generate this kind of culture into our team also, so that there is no such kind of problem on this in this world which the software developer cannot break, right? So modularity is the only attribute of the software product that make it manageable and maintainable. Once the problem is partitioned into the different processes or components, then it become more even manageable for the person or for the team to, and even to maintain also. So dividing the software to different modules, because every module is going to serve a function also. So in the current example that I have just put it here, there was a registration module, there was a login module, there was a transaction module, there was a add to cart module, there was a payment gateway. Different modules are serving different functionality to the software. So dividing the software to modules help the software developer to work on independent modules. But we have to ensure this thing in this way that once the uh, it is the job of basically development team who is leading the things, that module should be divided or it should be partitioned in this way that if one person is working on a module, it should not affect the modularity, it should not impact the functionality of other modules. That is why the module are kept always independent from one another. So I'm just going to give you some idea that this way, if I have partitioned the work, that if one person, a person is let's say working on this module, then it is not it will not impact the functionality of let's say B person and all and C person all. But if there is a common module between these three, and if D, I have kept its name as D, right? So if some sort of changes is to be applied onto the D, then it will definitely impact the A, B, and C also, right? So again, it depend upon situation to situation. Sometimes certain things are really unavoidable. It will really impact the thing, but we should keep it minimum. This idea must be clear in our mind. This kind of thing we have to keep in our mind. So it encourages because software development is not a one-man army show. It is a team effort. Different people are indulged into the different aspect of the software. So modular design will also encourage the parallel development effort because it will save the time and cost. Because initially in the initial phases of the software development, or not the software development, rather in the early 90s, there was a software crisis. The demand of the software was too high, but supplier was too less. So, but nowadays, every time, whenever we think of anything, then in the next day we hear that okay, the things are launched basically. So, how this gap is being overcome? Was just because of the parallel development which was encouraged into the software development, and modular design has given a radical move to this particular thing, that now there is no software development crisis into the this industry. Before we think, sometimes the things are already there into the market, right? So it helps us to create a independent module oriented software also. Modular design gives such a innovative approach to the development aspect of the software. Another is that yes, there should be a balance between the number of module and the integration cost. Because if modules are there, then that must be integrated among with one another. But we have to take care of the integration cost also. So although more number of modules make the software more manageable and maintainable, although software engineering principle don't rely or don't trust on this principle also, that if you think that the more number of modules will be more maintainable, it's not happen all the time at the same time. So as the number of module increases, the cost of integrating also increases. So we have to take care of cost aspect every time, whatever decision we are taking, or things are going on. So we have to evaluate all these things. So modular design, while applying the it should be minimum. So high cohesion and less coupling is a recommended practice at the part of software engineering. Function strength of the software module. This is the degree of interaction between module, like the way we, let's say I'm taking the example of an emailing software. If I have draft the entire concept of, let's say, email, or even attach everything, but I haven't, put any email ID into the to section. So that mail will not shoot to no one. No one is going to, receive it, even after you have done each and everything, because it is the now here the things are coupled, because until and unless I will not put anything onto the to section, my mail will not reach to the recipient basically, right? So once that parameter is satisfied, then the things will go on to the next level. So that dependency is coupling, and that independentness is called as a cohesion. In the same example, because I haven't mentioned any email ID into the BCC part or CC section, so it will not impact that. Okay, the recipient will still receive my email that receiver will receive the email whose ID I have mentioned into the to section. So this is a small example that I just want to quote to get an idea so that you all can relate that how the cohesiveness and coupling work together, because they all are these are the aspects that we implement into the implementation of the module basically. So highly cohesive system require little interaction with the system module or external module. There are several types of cohesion which are arranged from bad to best. It is approach. Cohesion. There is a coincidental cohesion, logical, procedural, and communicational cohesion. So this is the worst form of cohesion where module performs number of unrelated tasks. And why it happens? Because of the communication gap. In the first class where we talk about the introduction of the entire software engineering, I have shared one matrix with all of you that in software engineering, 70% of the problem arises because of lack of communication. So to lead a team of successful, to lead a team of software developers, we have to firstly ensure that all the communication should be proper and it should be correct also, so that this kind of coincidental, that worst form of scenarios can't be avoided basically. It can't be zero, but it can be avoided. It can be little also, right? And it can be done only with the help of communication, by making the communication better. So logical. Module perform series of action but are selected by calling module. So yes, there is a logical sequence of operation that must be done. If I am not a registered user on your application, how can I log in? And if I'm the login, then again the things will go to the next level. So these are the things which are logically connected with one another, right? Procedural. Module perform a series of steps. The element in the module must take a single control sequence and must be execution in specific order. Although I am taking the example of an e-commerce transaction, we all used to not daily, but most of the time we all prefer to go for online shopping and all. Let's say I visited to the, Amazon, I look for some fancy watches, I kept a few of the, models into my add to cart, and then from add to cart I have chosen one and again taken it to the payment gateway. This is entire, procedural cohesion is going on into this journey of transaction. So we have to plan this journey, what user experience we want to generate, what kind of things can come out or are required to be implemented into this journey of transaction. That will be covered into the procedural cohesion. But this another important thing is that until and unless that customer has put everything onto the it is add to cart, that aspect is reflecting only my interest part, but that item which I have taken to the payment gateway, that is actually completing our entire procedure part of the customer journey. So cohesiveness reflects each and every aspect that must run in an independent way. Putting everything into the add to cart will not ensure that I'm going to purchase all the model which I have kept into my add to cart, into my cart basically. So everything is done in a cohesive way in terms of software, because any e-commerce application is also one of the example of a software basically. Communication. All element in the module is executed on the same data set and produce the same output data set. Coupling, which is defined as a degree to which a module interacts and communicates with that of the another module to perform certain tasks, because the things are coupled. So my mailing example, I have already taken this example, which was reflecting a complete scenario of how the things are coupled. Until unless you will not mention any email IDs into the to section, there should be minimum one ID at least. So then only that transaction can be completed. So if one module relies on another, the coupling is said to be high. So low level of coupling means a module does not have to concern with the internal details of another module. And when you are going to write the your synopsis part, then it is again the recommendation for the part of IGNO that you have to mention reflect the functionality of each and every module into the synopsis part. Sometimes students do everything, but they mention the name of every module also, but they don't define the functionality in terms of description of each module. Although once you write anything that we have kept registration module here, login module here, add to card module here, payment gateway module here, but you have to exclusively mention this into the synopsis section also. Right? Types of coupling. From lowest of coupling to worst coupling. So there is another. These are the different aspects of the coupling. That data coupling, in which one module interacts to the parameter, like module X passes parameter A to module Y. I'm taking one example from your programming part, where you have done the programming with the help of call by value, call by reference, in which there is an actual parameter, there is a formal parameter. Actual parameter, they are copied to the formal parameter, then the same parameter is being reflected in terms of output. So that is possible, because of data coupling only. Stamp coupling, in which the modules share some composite data structure, right? Sometimes arrays and different data structure we use, so that is shared among the different modules. That is called as a stamp coupling. Control coupling, one module control the logical flow of another module, like we do into the, if age of the person is, let's say, greater than equal to 18, then the person will be entitled for taking the voter ID card, otherwise not. So that, the kind of, flow or the jumping of modules, passing on some criteria, that kind of coupling is called as a control coupling. So that you must have already applied into that C or C++ or Python, other programming languages and all. There are other types of coupling also: external coupling, content coupling, sequential coupling, and functional coupling. So external coupling, in this, the modules share external data format. It is mostly used in the communication protocol and in the device interface also, because it is the integration of many aspects of the implementation of the technology basically. Content coupling means one module modifies the data of another module. Sometimes the facts and figures get updated, so we have to update that thing, and all that is coupled. If one parameter will impact, then it will definitely impact other aspect of the data, which is coupled with that transaction basically. Sequential coupling means the output from one element is the input to some other element in module. Such module which operate on some data structure is called as a sequential module. The way we do into the, let's say, login, or again not login, we can take another example also. There are lot many things which happen in the sequence basically, right? Functional, in this, the module contain elements that perform exactly one function, because entire functionality of the software is reflected in terms of how the things are coupled with one another. So yes, there are different disadvantages of coupling also. Although you should remember, not remember, rather mention it when you are about to answer this particular question, that ideal software engineering practice says that coupling should be less, but cohesion must be high. Keeping in view of all these aspects, there are certain disadvantages of coupling also, that is difficult to reuse because the things are much coupled. So sometimes it becomes, I want to reuse that particular software, but the things are so coupled with one another that it takes extensive effort to to reuse that particular code. So dependent module must be included. That this is because dependency is there. So because this, and now it has become the disadvantage basically. Difficult to understand the function of module in isolation. If the things were coupled, then we were able to understand. But once they become isolated with one another, then it becomes really difficult to understand. So this kind of challenges we have to face when the things are coupled. So you have to mention. Now, what all are the different parameters that we have to keep in our mind while designing the interface that we are going to cover. Interface design is the most important part of the software design, because it is the only interface through which user or admin or different kind of entities or stakeholders interact. So it should be planned in a very logical way. So there are, yes, every interface must have a goal and intention behind it. What sort of idea you want to reflect to the customer or to the client for which they have to input or some sort of data into that interface. That goal and intention of the task must be identified with the help of your interface. It means your the design of your interface should be like that. It should reflect the clear idea or call to action to your client. You have simply said me that enter any number. I have entered, let's say, -7. So you said that you have entered a wrong code. So you haven't mentioned me that I don't have to enter the minus number, or even I don't have to enter the 0 number. Being a end user, being a client, or being a the customer, I can put anything, whatever is coming into my mind. So now you have to make some amendment into your design so that you give a clear call to action to your client that you can enter any positive number between 1 to, let's say, 100. So that goal is so that for what purpose you are asking for some input from me, so that that goal can be achieved, right? Use of consistent color scheme, messages, and technologies, that again plays a very important role in creating an effective interface. Your how you have aligned the things, how you have structured the thing, how the things are coupled with one another, and what terminology, what message you have communicated. I have to move to this place, but your arrow is giving the idea that you should click here. So it is a totally mismatching thing. So whatever idea you want to communicate, that must be clearly reflected with the help of your interface. So again, it requires extensive planning in this context. So designing is all about the planning of the placement of different component and connection or logical connectivity between different components. So apart from this, we have to develop the standards for good interface design, and we have to adhere to it, or we have to stick to it also. We have to ensure that every key team member, they should ensure all these standards also. Use icons wherever possible to provide appropriate message. If you want that your company is also available on different online platforms, then instead of writing Facebook, LinkedIn, Twitter, and all, why not to put the icons of all these things? People are more friendly with these icons. They will feel more connected with this rather than your words and all. So use proper icons or logo or wherever graphics you think that seems to be more appropriate and all. So allow user to undo the current command. It happens that sometimes you are asking for my age and I have input, let's say, -3 and all. So I think, okay, I done some mistake. So allow your user to re-enter certain things or undo the current actions and all. Provide sensitive help to guide the user. It is it should be the prime goal of every software engineer to provide the sensitive help to the end user, because they are new to your interface. They may be your visitor, but you want to make them customer also. So this transformation from visitor to the customer will always encourage if you are going to provide some sort of help to the people who want to really come to your site and all. Provide keyboard shortcut keys. Some people are very friendly with the shortcut keys, and also your interface should have such a capability also that they should support some sort of keyboard shortcut also. Design principle. There are certain mindset that we have to keep in our mind. These design principles are what? Your design should be easy to recover. That ability of your design to recover easily is this property of any design is called as a recoverability. So the system should provide some resilience to user errors and allow the user to recover from that error. This might include an undo facility, confirmation of the destructive action, that is called as a soft delete. Even sometimes when we do some sort of transaction, they ask for that, are you sure you want to delete with this particular transaction? So that asking again is a kind of soft delete. So that kind of feature must be there by designing into the software, specifically if some very sensitive transaction is going to happen. User guidance, some user guidance such as help system, online manuals, they should always be supplied with the software so that your software can be used. The user friendliness of your software can be enhanced. So this must be one of the recommendation at the part of design principle. User diversity. Whenever we are going to develop any sort of software, then again every software revolves around the target audience. So we have to keep this idea also in our mind that the user diversity, who all different users are going to use that software, that must be there. Yeah.
Ma'am, recoverability.
Recoverability.
Yeah, yeah. Can you please give me an example of this?
Yeah, I can take it. I have taken just to, let's say, when we normally use any sort of, let's say I was working in some MS Word or a paintbrush file. I have created some sort of creatives over there, but it is not appropriate. I just have deleted this particular file, and now I deleted files. You imagine the scenario. Every deleted file reaches to the recycle bin. So again, I go to recycle bin and delete that particular file that I want to delete. So then it again asks me, the interface asks me that are you sure you want to delete it, because once the data has been lost or it has gone from the recycle bin, then you need to do extensive work to get it back, right? So that recoverability is that this example I am quoting in this context, so that because it is asking again from the user that are you sure you want to delete this particular file, is a kind of reminder that if your mindset has been changed, you want to recover it, you just press the restore button and you will be able to get it back. But if the things is deleted from the recycle bin, again, because in software there is no challenge, everything can be done. Yes, it could be cost effective, it could be time effective, but again we are having different recovery software also with us so that we can get it back. But the point is this: if the things are recoverable, then this ability of the software is called as a recoverability. You got your answer? Your query is answered?
Yeah.
Oh.
And it should be with all type of software,
Yeah,
right?
it could be. This is one very small example that we popularly, used to apply every day, right? So that's why I have taken this example so that you can relate it with this concept. So designing principle should revolve around this aspect, that sometimes even this was an intentional or narrated example, but this can happen accidentally also, na? In my absence, someone has used my system, or sometimes even with my some shortcut keys, accidentally I press some certain keys and the things get into the recycle bin. It can happen also. So such kind of recoverability features or soft deletes really help us to recover back just by clicking back to the restore button and all, right? So this was all. I think I have covered this user diversity part also. Yes. So user diversity, the kind of user, the administration or end user or stakeholder, every kind of the competency level of each and every user, and the kind of requirement or the kind of transaction or processing that every user has to apply into your software, that must be served. So this is again this part. So now our unit 3 is finished. So I'll start. Okay, no problem. Okay. So quickly.
Next class would be on 2 p.m. right? Your class is
practical class.
Practical class. Okay. One thing, ma'am. Actually, I thought that the schedule has changed, right? Can you please share me the new schedule? What is prepared for G1 group?
Actually, no, I haven't got such a kind of information, but schedule I am having. According to that, let me check. Is there any?
Because last Saturday there was 3 classes. Now there is 2 classes of yours.
But no, I'm concerned with the software engineering. Achha, yeah, there's the schedule, revised schedule. I have just got it.
Please share. We will take a screenshot of that.
Okay. I will share into your group, G1 group. I will just forward. I am having WhatsApp message. I will share it. You everyone just quickly keep your video to be on so that I can take your attendance.
Okay.
One more. Okay. Yes. Assignment part is done. Thank you everyone. I'm having another class at 11 p.m. 11 a.m. rather.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Bye.
Thank you.
Bye.
Thank you, ma'am.